Okay, so we'll start with the cross applications concept. In the cross applications concept, what exactly is cross applications concept is what we need to understand. So the first and foremost is like the cross applications we have. So we'll start with the cross applications. Before this, we'll understand what exactly we do in the cross applications. We have SAP application connecting with non-SAP applications. So SAP applications connecting with non-SAP applications. So for this, like you know, so within SAP and non-SAP applications, if at all, if we have to get this uh, exchange of data between SAP and non-SAP applications, or from SAP to SAP applications as well, we'll be using this cross applications. So cross applications is a concept in which we actually send the data and receive the data between the SAP and non-SAP applications. So if you are going ahead with the SAP and non-SAP applications, then SAP and non-SAP applications, we need to have an interface. Let's say we'll take a simple example here. Let's say there is one guy who's talking in German language, and there is another guy who's talking in English. So there should be one person who knows both the languages, who can translate German language to English and English to German language. So this is something which has to be there should be a translator. Similarly, just like we have a translator, here from SAP to non-SAP applications, we have something called interface. So between any two softwares, if you want to exchange data, it should be through interface. So interface is something which will enable us to send and receive the data between the multiple systems. So this is what we have, interface. Interface will send and receive. So it is like a translator. This is also called as third party tool. Third party tools. Sometimes in some terminology, they're also called as third party tools, which will connect this both the systems. And so this interfaces is a separate software which is mandatory between the SAP and non-SAP applications, for that matter, between any two systems to understand both the languages. So this is what happens. So in this context, we have the first concept which was introduced in the world is EDI. EDI stands for electronic data interchange. Electronic data interchange. Now, electronic data interchange is something which was started in 1964. Okay, and you hope you all remember that SAP was started in 1972. So I'm revising that concept is because electronic data interchange, the EDI was started way back before the SAP was actually introduced. So even before the SAP was introduced, EDI was introduced. So then, like this is something which is nothing to do with the SAP. It was a global concept which was been adapted by SAP in 1972 to exchange the data between SAP and non-SAP systems. In fact, not in 1972, late 1970s. Okay, so then they came up with this. That they realized that they have to come up with their own software. Then they came up with ALE. ALE stands for application linking and enabling. This happened in 80s, and it became very popular in the 1990s. ALE IDocs concept was popular in 1990s. So now after that, we have something called RFC. RFC is also a global concept. It's a universal concept. It's a generic concept. RFC. What the RFC stands for? RFC stands for remote function call. RFC stands for remote function call. So RFC remote function call is just for exchange of data between SAP to SAP systems. Let's say our vendor is running on SAP system. Let's say our customer is working on SAP system. If they are working on SAP systems, then it's called they can use the remote function call concept to exchange the data between the SAP to SAP systems. And then now, all these things, the third party interface tools, the interfaces that we are seeing here, were not manufactured by SAP. These softwares had been, prepared by various other companies, which were then later certified by SAP. Let's say we have, say, TCS is there. Now, TCS has created a interface which can get the data from SAP to Java. So to SAP to Java, TCS has built a interface. This interface that TCS has built, uh, we should be sent to SAP to certify. So when SAP certifies this, then this will be available throughout the world, so that anybody can come to TCS and purchase that certified interface. So there were some issues, like some clients were not comfortable going to some third party and again purchasing the interface. They insisted that SAP has to sell them. It's not the third party. So if, let's say, there was a company who, like, it's not a company, it's an organization. So it was a naval defense system for a country, for a very big country. So for the navy, okay, for the navy, they wanted to implement the SAP. So in that case, they were not comfortable going ahead with third party tools, and then they have to go to the third party company and purchase that software. No, they were not comfortable with that. So these kind of issues came up. So instead of stopping here, and they insisted that the SAP has to create their own interfaces. Instead of creating interfaces, what SAP did is they introduced completely a different module that's called XA. XA stands for Exchange Infrastructure. Exchange Infrastructure. Then we have PI, Process Integration. Then they came up with PO, Process Orchestration. The process orchestration is the latest one. So the concept of all these three XIP, these are the version changes. Okay, these are not different technologies. These are just version changes with some upgradations. So obviously, for a new technology, we'll be having upgradations, right? So in this XIPIPO, the common thing is we don't have interfaces. In place of interfaces, they have developed something called adapters. And for standard exchange of data, for example, from Java to SAP, or .NET to SAP, some standard ones, they have actually created something like these are the interfaces, the common interfaces that we have. The common interfaces that we have here were actually been given. Now they have standard adapters in it, which we can make use of. If you don't have an adapter for a particular exchange, we can create our own adapters. Create our own adapters. So we can create our own adapters. So interfaces, we have interfaces. This interfaces, in the place of interfaces, we have the adapters for this XIPIPO. But whereas the ALE concept is something which needs the interface, if at all, if you are exchanging data between SAP and non-SAP systems. Now what we have to remember here is that SAP had been working on the exchange of data in various techniques. And even though XIPIPO are still in the place in the market, they have now XIPI have been become obsolete. Obsolete in the sense outdated. Now we have only PO. We just have the PO. So PO stands for process orchestration. So process orchestration, in this we have to go for the adapters. We'll create our own adapters. But even then, a lot of people will still use ALE because ALE is inbuilt tool for SAP. And XIPO we have to purchase it as a separate software. Yeah, and that has to be purchased by the company. But ALE is inbuilt. So let's say if a company wants to exchange data between SAP and any two systems, for example, just .NET and Java, that's it, or some website HTML and Java. So only one or two, then it is better to go for the interfaces rather than purchasing the adapter, because adapter will be very costly. Whereas the XI, we have inbuilt adapters, but it will be a bit costly. Adapters will be comparatively, uh, you know, uh, less cost. Okay, so that's the reason. ALE is an inbuilt concept. Only the interface is what we have to purchase. ALE concept is inbuilt in SAP system. So, okay, so let's go ahead with the EDI concept. Electronic data interchange, as I told you, is completely outdated. But even if in other softwares, even if you start working in some other technologies also, we will definitely come across EDI concept and RFC concept, because RFC concept and EDI concept are globally generic concepts. Okay, and ALE is something which is specific to SAP only, and XIPIPO also specific to SAP only. In fact, they have built it in such a way that even you can exchange the data between Java and .NET also. Java.NET also we can exchange the data, but people don't purchase it for that. They purchase it only when they come across SAP. Okay, so now with this clarity, let's start off with the ALE concept. ALE is application linking enabling. So introduction. So SAP ALE is SAP's technology to support distributed yet integrated process across several SAP systems. So the middleware tool, okay, so the third party tools or the interface tools are also called as middleware tool in SAP's business framework architecture. ALE can integrate ALE can integrate business process and functions between R3 system and non-R3 system, means and that SAP system and non-SAP system, as well as between loosely coupled SAP systems. So once upon a time, we always used to refer to the SAP systems as R3, but now we have ECC and we have the S4 HANA. So this is what we have. Okay, what are the benefits of ALE? So these benefits of ALE which we are talking about here are basically in reference with the EDI, because in EDI we faced a lot of problems. Those were actually overcome in the ALE concept. So communication interfaces allows connections, integration with non-SAP systems, distribution of applications between different release systems. So any SAP system can be upgraded to a new release without affecting the existing functionality. Once upon a time, when we had the EDI, we had a couple of issues. So ALE has functions for monitoring messages flows and handling communication properly, thus providing the reliable distribution. So this is what we have. So we'll discuss that. So in any process, whether it is EDI, whether it is ALE, we will have outbound system, inbound system, and exception handling. These things we'll discuss. Outbound system, inbound system, and exception handling. Okay, so we'll just discuss one example here. The sending system, if some system is sending sending the data, so the sending system is called outbound system. It's called outbound system, and the receiving system is called inbound system. Okay, so now ALE, what exactly is ALE? ALE is the process. Okay, so let's say we have in the outbound system. Let's take a simple example. Like this is let's say this, sending outbound system is say some SAP system, and inbound system is some Java, or say outbound system is some Java and inbound system is SAP. Either of this, okay. So either of this can be possible. So the example which we'll be discussing in the slides will be SAP to SAP system. So we'll consider this outbound system also SAP and inbound system also SAP. In that case, there is no need of interface or the middleware. Okay, so we just have to go ahead with the just a connectivity. So that connectivity is the bridge. Let's take a simple example here. So let's take for example, this is a simple example like DXE. This is a DXE 1000, and this is DXE office. Okay, so due to the effect of various issues, what DXE proposes is they'll build their own housing system, housing buildings, and then build their own DXE office, and we don't have to step out. We can just directly step in from the outbound system. I mean, like the DXE housing to DXE office directly. You have a bridge at the 10th floor, wherein it connects this building to that building, and you can go and start working. So nobody from outside will be allowed into these two buildings. So let's assume that. So if you want to go from this building to that building, the first thing that you need is the bridge. That bridge here in our SAP systems is called the ALE process. ALE. The ALE process is the bridge between the two systems. First one. Then okay, ALE bridge. Now this ALE is the bridge process. Once it's been established, you have to send. If it see, if you are going from DXE housing to DXE office, you'll be packing your box, a lunch box. So how do you pack your lunch box? The lunch box is packed in some container, right? So the food we pack it in the container. Now similarly here you have to send the data. You have to send it from system A to system A to system B. So if you want to send the data from system A to system B, if you want to send the data from system A to system B or receive that, it's like there should be some container. Just like for carrying your lunch, you see, if I'm going to office from home, I cannot carry the lunch in my hand, right? I cannot catch the food in my hand. I have to have a container for that. So that container is nothing but here IDoc. So IDoc is a container. Okay, what is an IDoc? IDoc stands for intermediate document. IDoc stands for intermediate document. This intermediate document is something which we will be using for filling up the data. So we fill up the data in the intermediate document, and this IDoc IDoc is like a container, is what I said. So we have compared that with the lunchbox, right? So in this lunchbox, you cannot mix up everything like you might have chapati, curry, rice, dal, and curd, then some desserts, maybe. Okay, so if we are proposing that five different items are there, the five different items cannot be put in one container and mix everything. It cannot be mixed in one container. You have to make them in separate containers, because they are not they have to be used separately. They have to be eaten separately. Similarly, here also, for example, you have material data and then you have employee data. So material data and employee data, both these data are something which does not have any link between them. There's no common field, and there are two different separate data, so you cannot join them also. So we keep these things in a segments. So there will be an IDoc, the intermediate document, and inside this we'll have segments. Inside there can be multiple segments, segment 1, segment 2, or something like that. Segment 1, segment 2. Okay, segment 1, segment 2. Now these are the segments. These are the segments that we have. So there can be n number of segments, just like we have the different portions in the container on the in the lunchbox. We have this segments. Now let's say this tiffin box is there, and if let's say DXC, your organization has given same kind of tiffin boxes or the lunch boxes for all of you. Every one of you is carrying the same kind of a lunchbox. Now, how do we differentiate? And we have to all keep the lunchbox at one place, and in the canteen probably, and in the canteen only we have to take it and eat. So if you put them in the canteen, so there's no way you have to find you can find it out, because there can be n number of people with the same kind of box, with the same. So what you do is you have an idea. You keep a cover or keep a tag which will easily tell you that this is your lunchbox. So that is kind of a tagging. Okay, I'm going to tag. So the tagging here for the IDoc is the message type. Okay, this is called the IDoc type. Okay, above this we'll have a tagging called message type. Now what does the message type do is message type will identify that IDoc type, and there can be multiple IDocs under the message type. There can be multiple IDocs in the message type. So we have segment 1, segment 2, and all these things. Okay, so this is how we have. So we have segments, and all the segments will be in one IDoc, and this IDoC is linked to a message type. This is what we have. Okay, so now we'll just see how it will work and all these things, but this is how it is. Okay, so we'll go further. And we were talking about the outbound system and inbound system. So for outbound system there is some process, and inbound system also we have a process. We'll understand what exactly happens in the outbound process and inbound process, and then exception handling. What are these three processes, what will happen, and how do we fix it is what we'll discuss now. So here we have outbound process, inbound process, and exception handling. So in this we have the outbound process, inbound process, and exception handling. So here we have the start outbound program. We have this outbound ALE program, and outbound ALE program, when it executes, it brings in the data from the repository, means from the database tables. It will bring in the data from the repository, and then it will generate a master IDoc. Okay, so there is a master IDoc that gets created here, and that master IDoc, what is a master IDoc is? A master IDoc is something which will have huge amount of data. It can have multiple tables of data, multiple values of data. So this is something which we have this. And then we have the ALE service layer. Then we have the communication layer. Okay, so here we will understand more in detail about the master IDoc and communication IDoc. Master IDoc and communication IDoc. Let's understand about master IDoc and communication IDoc. Now this is a sending system. Sending system is called outbound system. We know that. Now in this, what will happen? The data is there in the database table. So what will happen? The first thing is database table. the data is picked up from database tables, and that data will be filled up in a master IDoc. Now this master IDoc will pass through uh, the filters, and then communication IDoc gets created. This communication IDoc is something which will be sent to the receiving system. Communication IDoc sent to receiving system. Now, what is a master IDoc? What is a communication IDoc is what we need to understand. Let's say the data which we have, somewhere around 100 fields are there with uh, say 1 million records. So this is what the entire data is picked up in the master IDoc. But what we observed is all these fields are not required in the receiving system. In the receiving system, we need only few fields. In the receiving system, we need only few fields, not all the fields. Then what we will do is we will go ahead with receiving system. We'll be having we'll be going ahead with the receiving system. So receiving system needs only 10 fields with 1,000 records. Then we filter this. We filter this data based on this number of fields and number of records. We filter this, and the filter data is what we are going to present it in the filter data is what we are going to put it in the communication IDoc. So that is what we are trying to understand here. So in this, we have the master IDoc. It will pass through the ALE service layer, just like it's a filter as actually. So then we will see what is required for the receiving system, and according to that we'll go ahead with. Okay, so we'll go ahead with the receiving system, and this receiving system, whatever we have, will get the communication IDoc. But if you observe, there are 4 different communication IDocs here. So each communication IDoc is prepared for a different receiver. It might be very much possible that there can be multiple receivers, but at least one receiver is mandatory. But in the scenario which we are talking about on the screen, which has 4 receivers, so each of the receivers will get one communication IDoc according to what is required for that particular system. So let's say master IDoc is common. It will have all the data without any filters. Okay, but then we apply the filters according to the receiving system and prepare different communication IDocs for different receiving systems. So then we have some concepts used in the outbound system is the message control and change pointers. These are the 2 ways in which we can trigger the IDocs. So message control is a cross-application technique used in pricing, account determination, and output determination. And it gets triggers when the alien outputs for a business document. So message control is something which we purposefully call it. But the change pointers based on the change in the document. So let me tell you this message control. So there are 2 ways of triggering this triggering mechanism. There will be 2 types of triggering mechanisms here. One is the message control. We have to run it exceptionally. Means we have to run it. We have to run a program. Simply speaking, we have to run a program or run a background job which will trigger this load. Which will trigger this process. Which will trigger the process. But no, in the message control, in the change pointers, in the change pointers, you don't have to trigger anything. Let's say you have just created or changed a something like mm02. You go to mm02 and change material. The moment you change the material, automatically that data can be updated to the vendor. Okay, so immediately when you change it, it gets updated. So when you click on save button in the mm02, automatically this IDoc will get this process ALE process will get triggered. ALE process will get triggered. So that is a change pointers method. So we have to run it exception outside, that is message control, and we can do it with change pointers as well. These are the two things that we are discussing. These are the triggering mechanisms. Now we have selection programs. So in selection programs, they are typically implemented as function modules. We'll see what are the standard function modules that we have. To generate a master IDoc, we have a standard function module. Extracts application data and creates a master IDoc. A selection program exists for each message type. We'll see that. And filter objects, they remove unwanted data from the each recipient of data. Port definition, they are used in the outbound process to define the medium in which documents are transferred. ALE uses transactional RFC port. And now there are different types of RFCs which we'll discuss. There'll be the synchronous RFCs, asynchronous RFCs, and transactional RFCs. And then we have pooled RFCs. So we have RFC destination as well. It is a logical name used. Okay, so what is RFC destination also? We'll see that. So basically it will be given a name. Now partner profile, it specifies logical names, IDoc type, a message type, a transaction RFC, packet size, all these things will be mentioned in the partner profile. And processing the application layer, so these are the processing what exactly we do in the processing application layer is we create a program, and in this master IDoc is stored in memory, and the master underscore IDoc underscore distribute is the function module. This is a function module name, master underscore IDoc underscore distribute, which actually is used for passing it to the master IDoc. So whatever data is there which will pass to the master IDoc, will use this master underscore IDoc underscore distribute. Then we have the receiver determination. Receivers are determined from the customer distribution model. So IDoc filtering. So IDoc filter is specified in distribution model. If data record doesn't meet filter criteria, it is dropped. Segment filtering. A set of segments that are not required can be filtered out. So field conversions. So we'll be discussing about these things in detail when we have the flow. So field conversions, I'll just let me tell you that if one particular field is in one unit, it carries one unit. For example, we're counting everything in kgs, but you want to convert into grams, so we can do that to field conversions, or we can have the one currency to another currency, those kind of things. Version change for segments, communication IDocs are generated, syntax check is performed. IDocs are dispatched to the communication layer. These are the different processes that we have in processing in the communication IDoc. So now in the communication IDoc, we use a function model called inbound underscore IDoc underscore process. In the outbound system, we have master underscore IDoc underscore distribute. Here we have inbound underscore IDoc underscore process. So inbound process architecture. So we have we receive the data. And what do we receive in the receiving system? In the receiving system of the inbound process, will receive the communication IDoc. This communication IDoc passes through the ALE service layer, and that again from that again it will pass through the service layer, and then we'll get the application IDoc. This application IDoc is something which will be used is again in the inbound ALE program, and that inbound ALE program converts the data in the application IDoc into an internal table format. Again there will be a function model which will be passed, and after that it will go to the database tables of the second system. This is the process. Okay, so we just discussed about the concepts of the outbound process and the inbound process. So in the outbound system, we have two types of IDocs. They are master IDoc and communication IDoc. Whereas in the receiving system, we'll have two IDocs. Those are the application IDoc and the communication IDoc. The communication IDoc comes inside the, if you see the arrow marks, you can understand. The communication IDoc first comes into the inbound system, then it passes through the ALE service layer, and that will be passed to the application IDoc, that will be passed through inbound ALE program. So this is what is the flow. You have the posting programs and pattern profiles. So this inbound IDoc underscore process is triggered as a result of RFC from the sending system. So this is automatically triggered. So we will be having the basic integrity check, segment filtering, application IDoc. IDoc is mass ready for dispatch. IDoc is fast for posting to crossing in the posting mode, exception handler. Okay. So these things we'll discuss in detail again. So there is a process of ALE setup. Okay. So there is a ALE setup. This ALE setup is done in sale transaction. As I told you earlier, this is not supposed to be done by everyone because it's a highly sensitive issue. Security also comes into picture. So whenever we are doing this logical system, whenever we are doing this entire ALE setup, we need to get a lot of approvals before starting this in the organization. So it's a very critical thing here. So let's go for define logical systems, assign logical systems to clients, define communication parameters, modeling the distribution, generate particles. This is other steps that we have. So this is the screen of SALE sale transaction, guys. When you open the sale transaction, something like this will open, in which we'll create logical systems and then we'll assign the logical systems. For example, we have we decide some we decide some two names, say Prajwal and Navin. These are the logical system names. Let's say some logical system names. Okay, Prajwal and Navin are the two logical system names, but we need to assign them to some two persons, any two persons. We catch two persons. Okay, person A, person B. I'm naming the person as Prajwal and naming the person B as uh, Navin. So that is assigning logical systems to systems. Assigning logical systems means first we are defining the names, define logical system, assigning logical system names. So first we'll be defining the logical system names, then we are assigning the logical system name to two different systems. These are the two things that we are doing here. So that's what we are doing here. So first we'll be defining it, then we'll be assigning it. So first we are defining logical system names and then assigning the logical system names. So first we'll define. In this, we'll be so for the sending system, we are giving the name as send underscore IDoc and receive underscore IDoc. But when we are creating the logical system names, in every system, in every in every project, we'll have our own naming conventions. According to the naming conventions, we'll follow. So here we have send underscore IDoc and receive underscore IDoc. These are the two logical system names that we are giving. Then we'll assign the logical system names to two particular clients. So here the client number 800, client number 810 are there. So for client number 800, we'll define as send underscore IDoc. We'll name it as send underscore IDoc. And client number 810 will define for client number 810. We'll give the logical system name as receive underscore IDoc. So once we have done this, we'll be going ahead with the RFC destinations. Once we have created the logical system name, then we'll assign the logical system names, then we'll be creating RFC connections. When we click on the RFC connections, then we'll go ahead with these are the RFC connections that we have, in which we'll go for the R3 connections. So in the R3 connections, we'll be going ahead with the receiving system. So here in the receiving system, we need to give the in the sending system, we need to enter the receiving system details. So once we give the receiving system details, and then it will ask you for the logon and security. So when we click on the logon security, we have to give the details, server details. once it's been done Once it's been done, we'll be going ahead with the maintain distribution model and distribute views. So once we click on the distribute model and distribute views, then we'll be creating the model views here. So then we'll be going ahead with the sending and receiving details. After this, we have to go for the partner profiles. So in the partner profiles, we'll be generating the partner profiles, which will come like this. And then once it's been done, so it's like we have established the connectivity. Okay, so I'll be doing it on the system and showing it to you, but make sure you don't do it on your own, because this is something which we need to understand, and we should not do, because it will become an issue again. So we'll go ahead with the next concept. So next concept is the IDocs. As we already know, IDoc is an intermediate document. Intermediate document is something which is simply a container. It's a data container and used for exchange of data between two processes that can understand the syntax and semantics of the data. Now we have ALE and EDI process, and IDoc is created. So in an inbound ALE or EDI process, an IDoc serves as an input to create an application document. So whether it might be ALE process or it might be EDI process, the container is required. So in either EDI or ALE, IDocs will be present. We have this, every IDoc has a unique number. Every IDoc will have its unique number. So there is something called IDoc number, and will be we also have having IDoc type. So IDocs are independent of sending and receiving system. So SAP to SAP as well as to SAP non-SAP system will have this IDocs. IDocs will be sending and receiving the IDocs, independent of direction of data exchange, can be used by both outbound and inbound process. So IDocs can be viewed as a text editor. Data is stored in character format instead of binary format. So we'll discuss that. So there will be two types of IDocs: basic IDocs and extended IDocs. We'll see both the types of IDocs. So as we discussed, an IDoc contains internally segments. So we'll create IDoc in the WE30 transaction, and we'll be creating the segments in WE31 transaction. Then we'll be going ahead and creating the message type, and then we'll be attaching this IDoc to the message type, which we'll see now. So every IDoc will have three records: control record, data record, and status record, which we'll see in detail. The ALE configuration. The ALE configuration we do it in SALE transaction. So SALE transaction, sale transaction. So in the sale transaction is something which looks like this. So I'm logging into this EHP6 server. So the logical system names have a particular naming convention, which we'll see. So here in the basic settings, we have this. Inside the basic settings, we'll have the logical systems, and in the logical systems, we have defined logical systems. So when you click on this, define logical systems, we'll get into that different names of the logical systems. So this is a table cross client. So we are saying accept, okay. And then here we have the sending system and receiving system. We have n number of names that people have given this. So now I'll go for a new entries. In the new entries, I'll give ECC. This is EHP6 sending system, ECC EHP4 receiving system. Let's save it. Once it's been done, okay. So we have created two names. We have created two names here. Then back, and once it's been done, we'll go with the assign logical system to the client. So when we select this, now we have to assign that name to one particular client. So client is a subtopic in the server, right? So now here we have 800 client, we have 810 client. So already something has been assigned to it. Now what we'll do is we'll go ahead with the, say let's say we have 066, okay. For 066, we can upgrade that value here. Basically, instead of this logical system name here, that is ID3CLNT66, we can go ahead and change that to the logical system name that we created just now, that is ECC EHP6 or something like that. So we can change that. And then we have this 809 client. So this also we can change this to the receiving system name. So let me change them actually here. So 66, I'll change this to ECC star, and we'll get the ECC HP6, whatever we created will be visible here. EHP6 is the receiving sending system. So we'll just save it. And then let's say 809, change this as ECC star EHP4. Save. And once it's been done, these are the, so first we are creating the names and then we are assigning the names to the respective clients. So once it's been done, we will go for RFC connection. The communication, in the communication we go for RFC connection. As we have SAP to SAP systems, we don't have to go for the interfaces or the third-party tools and all. We can go for the RFC connection. In this RFC connection, we'll go for this, click on create, and here the RFC destination name can be anything. So I'll give it as something like JH underscore CONN. So the connection type is mandatory. Connection type will give it as ABAP connection, ABAP connection, and then JH ECC EHP 6.0 to EHP 6 to EHP 4. Okay, this is what we're giving. So in this, we'll go ahead with enter. Now, the moment we say enter, it will ask you for the target host name. The target host name is something which we need to copy it from here. Let me copy it from here. So the target host name is 192.168.0.150. 1. 150. So then we have to say enter, and system number. System number have to be given from here. System number is something like system ID is blank. Instance number is 52. Instance number is 52. So we have 52. So we'll just say enter. The moment we say enter, automatically those will be copied here. If both are in the same network, this happens. Okay, so since we have the both the systems in the same network, now it automatically the name has come here. The IP number has been copied here and the name has come here. Now we will give the language, the client name, the number is 800, and SAP user password, whatever is the password of the system, we'll give that and say enter. User can be used for remote logon targets. Say OK. Now, once it's been done and saved, we can go for remote logon now. When you click on the remote logon, now we will click on the remote logon here. So when we click on the remote logon, now we have actually entered into the EHP4. If you see down here, we can see on the bottom of the screen, you can see EHP4. I can also show you more details here. So this is a EHP4. EHP4. Now we have this EHP4. We have logged in into the EHP4 now. So this is, we have successfully done that. So this is the connectivity between the two systems. We have established it. So we have established the connectivity between these two systems. So once this RFC connection has been done, Then we have to go ahead with the modeling part. In the modeling part, we'll have maintain distribution model and distribution distributors. So we just need to select that. So in this, we will be creating a model view. So there should be some model view that we have to create, in which we have to mention the receiving system name and sending system name. So we'll create a model view here. After creating the model view, we'll be generating the partner profiles. So model view is something which we'll be clicking on this, and then we'll be creating a model view. Display change and creating the model. So we have to click on this create model view. In this, we have to say jh underscore model. This model view, jh model. Say OK, and automatically this model view gets created here. So we just need to see at the bottom the jh underscore model view has been created. Right click on this. Right click on this. Then we have to go for add message type. So we need to create a message type here. We need to add the message type, and we need to add the filter type also. So add message type. So we'll just need to, when we say add message type, we need to give the sender system name, receiving system name, and then we have to also create a message type. We just need to create a message type and then get back to this so that we can complete this process. Okay, so this we'll do this. Okay, we'll do this once we create a message class. As of now, we'll just for our understanding, we can give that message. We can select the sending system name from this. These are the sending system names, the logical system name that we created, and receiver system name, and then message type. So once we create a message type, we'll come back to this and we'll maintain that. And this sale configuration which we have done just now is very very confidential, guys. So this is something which you're not supposed to do in the real-time projects until unless you get the proper approvals, because this might completely change the link between the systems. Okay, but what you can comfortably do from the ABAP perspective is the creation of IDoc and all. So we'll go to W30. So creation of an IDoc from the W30 is something which every one of us can do comfortably from the ABAP perspective. So let's say if you have created, there are a lot of standard IDoc types that we have. Let's say we have matmas start. So we'll have matmas 010203. So in this, these are the standard IDocs. So in this 05, matmas 05 is the latest one. Always we'll have 02, 03, 04. The last number will be the latest one. So we'll go for 05, and then we'll go on display. So we'll get these details here. So these are the details that we have here. Okay, these are all the segments that we have here. Okay, so we'll create our own IDoc type now, and we'll create our own segment, and in the segment we'll create our own fields. Okay, let's do that now. We have to start it with Z. So I'll go for zdxc underscore uh, mat, material details. We'll go for material details. So we'll go ahead with zdxc underscore mat is the material the IDoc name. We'll just click on this create. This is a create new IDoc for material. So say OK. Now here we need to create the segments. So we have to attach the segments here. First, attaching the segments, we have to create a segment in WE31 transaction. In the WE31 transaction, we'll be creating a segment. Let's say we'll create something like ZSEG underscore MAT1, and then click on create. Now we'll create something like segment for material. Say OK. And in this the field name is matnr, data element is also matnr. Then we have ERSDA, type ERSDA. So these are the field names that we are getting it from the Mara table, ERNAM. So I'm taking it from Mara table. So just three fields is what I'm taking in one the segment. So we'll just understand. So process by, if you give a process by username, only that process by username can modify that, or you can add some values to it. So we'll have person responsible and person process by. Two things will be visible here. So once this is done, we will attach a message type for this. Once the segment is created, and we'll attach to the this segment, we are going to attach to the IDoc type. Okay, so this is a segment type. We can have number of and multiple segment types can be attached to one IDoc type. So we will attach the segment type to our IDoc type, and that IDoc type we are going to attach a message type. So message class, we are going to send a message type. I'm not sure about. So we have, so W30, change, so creating new. Okay, maybe we'll create it some MAT1. Okay, MAT1. Now select this IDoc type and attach the segment type that we have created now. Z star MAT star. So we have ZSEG underscore MAT1 is the one. So in this, the minimum number of records. Let's say if you are sending the data from one system to another system, if let's say if the system one has some 10 records, if let's say system one has some multiple records, system two has another multiple records. So what we are saying is, if only when we have at least 10 records, you send it. Otherwise, you don't send it from system A to system B, something like that. So if you have one, I'm keeping minimum is 1, maximum is 100. If you have more than 100 records in that particular IDoc and the segment, what will happen is automatically it will go to the next packet. Okay, it will not be saving the same packet, it will go to the next packet, something like that. So we are dividing them, and minimum these many number of records have to be there in that IDoc to be sent from one system to another system. This is what we are doing it. And if you go for mandatory segment, until and unless data is filled into it, this segment, the IDoc will not go from system A to system B. Okay, so we might have some 100 segments also in one IDoc. We are going to make sure one, the mandatory segment will be here, will be visible. Say okay, save it, save. So now we have attached the segment to a IDoc. So at least one segment is mandatory for an IDoc. So once it's been done, we can go back to the segment. We can go to the segment editor, go to released. You can go and release the segment. We have to go through the W31 transaction. So in the so segment, once it's been done, so we'll go ahead with W02, sorry, W31. In the W31, we have to go to segment. Yeah, this one, edit set release. So we need to release that. Releasing in the sense, you are telling to the system that I'm not going to change anything in this. So we are freezing it, locking it, like kind of a locking it. Okay. So once it's been done, we'll go ahead and freeze or the release the IDoc type. Once the segment is been released and then the IDoc is been released, then we are going to attach a message type to it. Okay, message type is like a tag to this, with which we'll be using the message type to identify the IDoc types. So now we have done this. Now we'll release the IDoc type. We'll release the IDoc type. So we'll go to set release, edit set release. So we'll go for set release. Yes. Now this also has been freezed. Okay, this has also been freezed. IDoc is also. Now we'll go to WE81 transaction and we will be creating a message type. And the message type can be anything. So open display change. Say okay. Click on new entries. So we'll go ahead with a message type. We can create some message type. I'll create it as something like ZJH underscore MAT material message type. So save it. Then we'll go back and then we go back again. Now W82. So we'll attach this message type to IDoc type. IDoc type is in the sense the basic type. IDoc type is also called as basic type. Okay. So we'll go for new entries and in this we'll go for the message type. I don't remember that. So ZJH star. So we'll get this message type here. So ZJH underscore MAT is what we have done now. And the IDoc type that we have created is, I'll go for ZJH star. Oh, this is not the one. This is for DLF data. Something like, what is the IDoc type that we created just now? ZDXC underscore MAT1. So let's go ahead with ZDXC underscore MAT1. And the release is something like 700. Say okay, save it, done. So once it's been done, so we'll go ahead with this message type. Now we can make use of this message type. Okay, why did I give 700 there? So just let me explain you why did we give 700. So this is a release version, guys. Like for example, if it's a 6.2 ECC 6.2, we'll use 620. But right now we are using EHP 7, so we can give it as 700. So release 700 is what I have given. Okay, EHP 7. Because this is just a version of. Okay. Now once it's been done, we have done this. We have built the link. We have created the message type. Now we can go ahead and assign this message type to our model view, which we have done in the sale transaction here. So in the sale transaction which we have done, so let me quickly do this. Once it's been done, it will be over, guys. JH underscore model. So model view distribution, we have this. 69%. Okay. Add message type. So we'll go for this sending system. So sending system name will be giving. I'm not sure what is the sending system name of 800. It will be like something like. Let's understand that 810 client and no 800 client. So 800. I just need to check that in the logical system names. Let me just check in the logical system names. Just 1 minute, it will be over. So So if you see I 800, it's IDocs ALE name and IDocs ALE. So this both are IDocs ALE. So you get as IDocs ALE, IDocs star. It's not been operated like that. The technical name should be something like this. The logical system name. So T90 CLNT 800, T90 CLNT 800, T90 CLNT 800, and receiving system is T90 CLNT 810. And the message class just now we created it ZJH something, so that needs to be given here. So ZJH underscore MAT is the message type. So once we do this, the model view is been completed. So model view is completed. 800. Okay. 090. So it's given as 090 instead of 800. They're given it as 090. Now it's been created. So in this model view, we can see that there is IDocs server. So from where data is from going from where to where, and which message type has been created. All these things will be there in the modeling the distribution view. So we need to save this. Yes. So once it's been done, we can go for the distribution model and master data distribution, and we can replicate the data. Okay. So for that, again, we have to make sure that the connectivity is established with the 800 and 810 client. And so once it's been done, then we can go ahead with this. Because so this is a sale configuration that we are doing. And the most important thing from the technical point of view, what we'll be doing is we'll be creating the IDocs, and then we'll be writing the program also for that. Okay. That will continue in the later next session.